Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Today we are in the chapter 14 for the electronic circuits 2. The title is feedback and oscillator circuits. Okay, after we learn many aspects in electronics such as the power amplifier and then linear digital IC, now we will looking for another interesting topic in the electronics. This is the oscillator and the feedback. So you can see from the picture here, this is the feedback amplifier. We have this is the amplifier A, and then the input signal is coming from here. This is the Vs, and then come to the node, this node, and then come to the amplifier. This is the amplifier, and then we have the output over there. The output signal, it will be feedback to the input of the amplifier. The feedback gain is the beta. So after we amplify the output signal through the beta, we have the VF here, and then it will be make a summation with the input signal, so that will be the input of the amplifier. So this is the feedback, the feedback concept. And then if we put the negative here, it means that we put a negative feedback of the amplifier. For the negative feedback, we have the disadvantage, that is a lower gain. But the advantage of the negative feedback is the higher input impedance, and then more stable gain, improved frequency response, lower output impedance, reduced noise, and more linear operations. So for example, we will develop the amplifier, and then we need high input impedance and then low output impedance is like operational amplifier. So we can use the feedback, the negative feedback. And another advantage of this concept, the negative feedback, is we can get the stable gain. It will be important in the amplifier circuit to get the stable gain, and then also it will be reduce the noise. Okay, and at least but not least is the negative feedback will give the more linear operations. And we have many options of the feedback connection type. This is the voltage series feedback, voltage shunt feedback, current series feedback, and also current shunt feedback. So we will look for each connection type of the feedback. The first one is voltage series feedback, like this one. So we have the source or input source over there, and then this is the amplifier. Is we use the FET there, and then the input, this is the input, will be feedback. This is the feedback. Okay, so this is the input, and then this is the output, and then this is the input. The output, after we amplify the input, it will be back. We feedback through this line to the emitter or the source of this FET. So because of the output voltage over there, because this is using FET, so the output is the voltage, output voltage. It will be feedback to the in the series to the input. So we use this. This is a voltage series feedback, and then the feedback gain is AF is 1 over the beta is equivalent to R1 plus R2 per R2. This is the R1, and then this is the R2. Okay, so this is the feedback gain of this voltage series feedback. And the second is voltage shunt feedback. The output voltage is feedback in the parallel with the input. So this is, for example, this is the input, and then this is the output, we use the op-amp over there, and then for the voltage sun, the output voltage is fed back in the parallel with the input. So this is the input coming to the op-amp, and then the output voltage is feedback here, and then this is the parallel to the input. This is the input. So we call it the voltage sun feedback amplifier. And then the feedback gain is the AF, because the input is connected to the negative terminal here. So this is the inverting op-amp. So the AF will minus R0 per Ri or R1 here, Ri, the input resistor. Negative here, this is represent the phase difference. So this is the phase difference. Okay, this is the phase difference, the negative. And then the second is the current series feedback here. For the current series feedback, if you remember the before, the two connection before is about the voltage, and then this is the current. So the portion of the output current is feedback in the series with the input. So this is the input signal, and then this will be amplified over there using the BGT. So the output of the BGT is the current. So the current will feedback in the series with the input. So this is the feedback here. And then we can, this is the output. So this is the output. So the feedback gain or AF is I0 per Vs. I0, this is one, output current, per Vs. Vs is the input voltage. So we can represent by A per 1 plus beta A. So A is minus HFA per high IA, and then the 1 plus beta A become this equation. So we can get that AF for the current series feedback using this circuit is minus HFA per high IA plus HFA RA. RA is the emitter resistor here. And then the last feedback is the current sun feedback. For the current sun feedback, the portion of the output current is directed back in parallel with the input. So this is the source, and then this is the output. So this one is the feedback to the parallel with the input. This is the connection is the parallel, so we call it the current sun feedback. The IF of feedback gain is 1 I0 per IS. IO is the output current, IS is the input current. So this is the summary of the feedback effect. We have the voltage series, voltage sun, and voltage series, voltage sun, current series, and current sun. This is the gain without feedback. So VO per VI, VO per IA, and then this is the IO per VI, IO per IE, and then this is the feedback, this one, and then this is the AF. Okay. So this is the effect of the feedback connection in the input and the output impedance. So for the voltage series, the input impedance will be increased, the output impedance will be decreased. And then the current series, all the increase. And then for voltage sun, all is decreased. And then current sun, the input is decreased, but the output is increased. So in this case, you can, if you want to increase the input, for example, input impedance, and then decrease the output impedance, you can use the voltage series connections. But if you want to increase both input and output, you can use the current series. And then if you want to decrease in the input and the output impedance, you can use the voltage sun. And then the last, if you want to increase the output impedance and decrease the input impedance, you can use the current sun. Okay, so for the For the feedback, we have the many issue. The first one is frequency distortions. So if the feedback network is purely resistive, the gain with the feedback will be less dependent on the frequency variations. So because of the resistive impedance is didn't related to the frequency, so if we can make on the feedback network is purely resistive, so there is no frequency variations. But if the feedback includes the capacitor or inductor, and then both component is affect the frequency, so the frequency response will be affected by the feedback. And then for the noise and nonlinear distortion, the feedback network reduce the noise by cancellations. Okay, by cancellation. So the phase of the feedback signal is often opposite the phase with the input signal. And also nonlinear distortion is also reduced by using because the gain is reduced. The amplifier is operating in mid-range and not at the extreme. So for the noise and nonlinear distortion, it will be better if we use the feedback circuits. And then for the bandwidth of the feedback increase the bandwidth of the amplifier. So for example, if we didn't use the feedback, the bandwidth is B. So from this one to this one. And if we put the feedback, the bandwidth will be from this one to this one. Okay, so it's increase the bandwidth of the circuits. And then another one is the gain stability. Okay, the gain becomes more stable if we put the feedback, because of the gain calculation with feedback is based on the external resistive element. So if we remove the gain calculation for the internal variations of the beta and the GM, so the gain become the more stable. And then the last one is the phase and frequency considerations. At higher frequency, the feedback signal may no longer be out of the phase with the input. So the feedback is dispositive, and the amplifier itself becomes unstable and begins to not stable. So in this case, if we use the feedback in the higher frequency, so the feedback signal will be okay. I mean that is in phase with the input. And for the frequency consideration, we have to use the resistive component as main component for the feedback. So the frequency consideration will not affected by the pure resistive element. But if we put the capacitor and inductor, the feedback will be, the frequency will be distorted. So I think this is the first part of the feedback and oscillator circuits. Thank you for your attention. Good afternoon. Assalamualaikum warahmatullahi wabarakatuh.